Hello, this is Edgin Montiel, and this is going to be resuming off the last video where I was working on the CSWA Practice Exam. So I already have two videos before this one. There's one video where I make this part for you guys, and I do all three steps to it. Then I did another video where I'm talking more about the beginning, and I answer some of these other questions, where I did tell you guys a wrong answer, so I just want to make sure you guys know that on this very first one, on the drafting competencies, that the answers are really here at the end, and the answer was crop. So this one, the answer is it's a crop view, is what they did, not a section view. Section view is like when you slice it with a ninja sword, and I think we talked about that one in another video. So I did misspeak there. This one is crop. Just make sure when you take this test, you know what you're doing, as well as these other ones, because there'll definitely be questions on it. So I did that part, and then we talked about center of mass in the last video, because if you don't know what center of mass is, I think it makes it super hard to understand what you're doing in this assembly assignment. So now I'm going to jump right into this assembly. So when you do this practice test and when I sent it out, it comes with the parts. So the only good news about doing any assembly problem for the CSWA is that there's actually going to be a button that you click on and it has you download the parts. So when you download the parts, you just need to make sure that you put it somewhere that you know how to get to it. So I have them right here, and the instructions will tell you to open the parts, and I do recommend you open the parts. So I'm going to open this short pin first, and it's opening it as a part inside of SolidWorks, and it's going to ask me, do I want to proceed with feature recognition? And you tell it no. So the instructions tell you to do that. So I don't know what it does if you don't, but I'm just telling you what the instructions tell you to do. So same thing, long pin, I'm going to tell it no. And then the last one is this chain link, and I tell it no. So now I have all three parts open in SolidWorks, and I can toggle between any of them. So while I'm here in SolidWorks, I could always come up here to the left top hand corner and come to Window. And from Window, I can see all of my parts, and I can toggle or switch between them from here as I want to look at them. But really what I'm trying to do is make an assembly. So I could always come up to File and make an assembly from part, but whichever part I'm on, that will start that part as the base of the assembly. And it's very, very important that when you look at the SolidWorks instructions that you listen to which part it wants you to use as the base. So here in the instructions, here where it tells you you're going to end up downloading a zipped file that has the parts inside of it. Then you're going to open that part file, and it's going to ask you if you want to proceed with feature recognition, and you tell it no, just like I showed you. And then when you create the assembly with respect to the origin as shown in the isometric view, this is important for calculating the proper center of mass. So in this one, they want us to put the origin of the assembly that we're making right here at the top of this part. Because if we don't put it right here, we will get the wrong answer for the center of mass. Because the center of mass on any given object is always one point somewhere in 3D space, and we just need to know how to communicate that point that is in 3D space using the Cartesian coordinate system x, y, and z. So there is going to be an origin somewhere, which is where x, y, and z come together and they all equal 0. And somewhere relative to that point is going to be a center of mass that we need to get some numbers for to answer the question on the test. So SolidWorks wants us to build it in this orientation with this angle A, this angle B, and this angle C. And there's questions that correspond. Here's the angles A, B, and C. And here's the angles A, B, and C again. And the only thing that's really important is that the origin goes right here. So this is part like number 1. So I'm going to load that one in first. Sometimes the instructions will tell you to load in a specific piece first, but this one doesn't. It just tells you to make sure the origin is as it's shown. So I'm going to show you several things with the origin when it comes to this part. And then the pins are mated concentrically to the link holes, no clearance, and the pin end faces are coincident to the chain link side faces. I'm going to show you guys this too, but I'm also going to show you another cool way to get things put together, just because I was working on one of the other practice problems, and I think it's good to know this way to make things equidistant in SolidWorks when you're doing the mating for these assemblies. All right, so we're going to do these, but we're also going to do other things, I guess is what I'm trying to say. And then we're going to enter it, and then we're going to pick our multiple choice to get the right answer. And then SolidWorks has us change the A, B, and C, and we have to actually enter that answer. And this is just like how the test will be. It'll be multiple choice, followed by you have to enter all of the values by hand with only a 1% error allowed. And this is the scary one because there is only a little bit of wiggle room. Like you only get 1% across all three numbers, I think is how they use it. So the first thing I'm going to do is load in my parts into an assembly. So I'm going to go to File, and the easiest way, depending on what the instructions are, if they want you to load in a certain part as the start of the assembly, I would go for it. But if they don't want you to load it in as the initial part for the assembly, I wouldn't start an assembly with a part. So I'm going to go up here to File and then to New, and then I can actually make a new assembly. That way, when I start it, it doesn't have any parts in it right away. And because I opened all the parts in SolidWorks, it will automatically load them all right here for me off to the left. If I want to keep this window open and slowly add in my parts, then I need to hit this little pin, because right now, if I click one thing, this thing's going to go away, and I'll have to reload it. So if I want this to stay open, I click this little pin over here, and then I can see my full preview over here. So if you don't have graphics preview selected down here in the bottom left-hand corner of your properties window over here to the left, then you won't be able to see the parts as I'm clicking them over here. But you can pin this open. I'm going to click on chain link, and I'm going to drop in the three that we need. And I put this one in first, so it oriented that one with the origin. And now I'm going to put in the long pin, and I'm going to end up needing two of these. And then I'm only going to put in one short pin because I'm going to show you another way to add multiple pieces. So I have my parts in, so I hit check mark, and I have them all in. If I did not hit that little tack, that little pin to keep that property window open, all I would have to do is click on my assembly tab here, and then I can come to insert components, and then it just makes me do them one at a time ultimately. See how you would have to do it unless I hit this pin to keep it open, is what I was trying to show you guys. I can also right click on any part and delete them out of my screen in case I put too many of something. So that's also good to know. But then if I want to make multiples of these on my keyboard, I can hold down Control, and when I grab this part and hold down my left mouse button and move, it replicates it that way as well. So all I did there was on my keyboard, I held down Control, then I left clicked and held this part and then moved, and it replicated it. So you can easily replicate things here in your sketch pane as well. So the instructions want us to assemble this thing. So I'm ultimately just going to put it together first, and then I'm going to show you how to kind of move around the origins. So in any assembly, what we're doing is we're making, kind of think of it as sketch relations between different parts, except they call it mates in assemblies. So on my assembly tab, I click on my little paperclip, which is the mate feature, or the mate assembly feature. I don't know if it's a feature or not. And then so mates are always between two things. So I could pick the outside shell or the outside skin of that long pin, and then I can pick the inside shell of that one. And SolidWorks already knows, oh, it was trying to do something funny, but I want them to be concentric with each other. It's already giving me a hard time. I want to make a mate between this guy and that guy. And there it goes. Now it's automatically new to make them concentric. Obviously, SolidWorks isn't perfect. I don't know what it did there for a second, but maybe I misclicked something. But we wanted the outside circumference of this cylinder and then the inside circumference of this hole through that pin and make them concentric. Then I hit check mark. And that puts them concentric. So they share a center point now, which makes them awesomely connect together like that. But now SolidWorks doesn't know any constraints in this direction. So what I could do is actually pick this surface, which is that top flat surface, and then this flat surface. And SolidWorks already knows I'm trying to make those coincident or make them flat with each other. They're a part of the same plane now. I can hit my check mark over here, or I can hit check mark over here. SolidWorks gives me plenty of options. And ultimately, that's how I'm going to build these things together. All of them have to have 2 to 3 sketch relations, depending on how I'm trying to constrain it. If I do 3 sketch relations, it constrains it in all 3 axes usually, and that means it'll be completely put still. But if I don't constrain it in all 3 axes, then something will be able to rotate. So this is the part that I loaded in first, so you can't move this piece. But this one, you can't really tell, but it is actually rotating on here if I grab it and start moving it. So then what I'll actually do is unlock this piece. So because this was the first one that was put in, it's the first one in line here. But that also means that it's fixed in place. I know that this one's fixed because it has an option to change it to float. If I go and right click on any of my other parts, I can tell that they are floating because I have an option to make them fixed. That's also what this little F means right here next to the part, is that this part is fixed, and when this little dash means that it's floating. So I know that this part is fixed right now, but I'm going to right click on it and go ahead and tell SolidWorks to make it float, because now I can move this whole thing together because I'm moving around the origin, all kinds of crazy, because I want to talk about origins a lot on this video. So I'm going to finish assembling this guy though, so I'm going to keep doing my mates, and I'm just going to start putting this guy together a little quicker now, because you guys saw how I did that. So I'm going to make this pin concentric with there, and tell it that's good, and then I'm going to tell it this face is concentric with this plane, and those are good to go now, and then this cylinder is concentric with that cylinder, then check mark, and then this face is coincident with that face and check mark. Now, one of the other ones I wanted to show you guys, I'm still going to do concentric here and concentric there. Awesome. SolidWorks knows it. And now I'm trying to position this in between here, and I showed you how to make the plane of this and the plane of this coincident, because SolidWorks will automatically take the wheel there and try to make that one the case. But there was one assembly that we did the other day that was beneficial to actually do it a little bit differently. So I want to show you that sketch, or that mating here. So we've all done all our mates so far on this standard tab that's in this property window for the mate. But I'm actually going to click on this advanced tab now. And on this advanced tab, there's this option called width, and it lets me have these 2 fields of selection here. But ultimately, what you're telling SolidWorks is you want the surface of this and the surface of this to go into the blue box. And then the pink box would be this one and this one. And what SolidWorks can do is it can make them perfectly centered in there. So if this was a crazy shape and I wanted it to be perfect, this little blue cylinder to be perfectly in the middle of the outside of these 2 walls, this is a way that SolidWorks would do it for me automatically, and I wouldn't have to do any type of measurements. So this is a really cool one to know how to do a mate with, and I just wanted to show you guys that in this video. You don't have to do this one that way, because just doing coincident with these 2 surfaces will do the same thing, but I just wanted to show you that one. And then the last one, so we're going to keep going through these, is that one's concentric with that one. Oops, I was on the advanced tab still. Concentric. And then this, I'll do that fancy one again, so advanced. And then we're going to say the width. And this surface is a blue surface, this surface is a blue surface, and then this surface is a pink surface, and this surface is a pink surface, and it's going to be centered in there, which is super awesome sometimes. So it's a little more clicking, but you'll see on some parts maybe that might be a benefit to be able to do that. So the last one is this cylinder. It goes in here concentrically. And then I'm just going to do what I'm considering the lazy way now, and doing this coincident with this surface. And I think we're more or less together. Except I think I probably am 1 link short, aren't I? 1, 2, 3, 4. Yep. 1, 2, 3. Ha 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 ha. Well, at least you guys get to see me delete mates now. So I'm going to get out of the mating tool. So I hit this X. And down here on the bottom left-hand corner, I have all of the mates that I've made. So if I want to edit any of these, like these last 2, then I'm going to right-click on and delete, and then tell SolidWorks yes, and right-click and delete and tell it yes. and pull this guy out of there because we weren't ready for that. And now I can hold down Control on my keyboard and left click on this piece and pull it out to pull out another one of these. And then I can left click on my, or hold down Control on my keyboard and left click on my mouse and pull out another one of these parts. And now back into my mating tool and concentric, check mark, coincident, coincident, check mark, concentric, check mark. And we're going to do coincident this time because it's a little faster. Coincident, check mark, then concentric, check mark, and coincident, check mark. All right, now we got it right. So on my keyboard, I can hold down Control and hit number 7, and that's going to put me. This is a continuation. This is actually me cheating, so I'm going to just splice these videos together, but this is a completely different day that I am putting together with that video. But what actually had happened is I was working on that assembly, and I had put it together in so many different weird ways trying to demonstrate things for you guys that it was turned like completely backwards. And I was even like trying to put the angles on the wrong side of it. So it took me a huge amount of time to like try to make it right, and I did have it right before I went to bed, but I don't want to have to like splice all those videos. Um, so I figured I would just redo it really quick, so this can kind of show you guys the right way. So what I had showed you guys before was the part that we're making, and the biggest part of this is to read the instructions first. Whenever you do an assembly, read the instructions first. So download them, open them, the files, and click no. And then we're going to do create the assembly with the respect to the origin shown in the picture. So the biggest part of this whole assembly thing to get this answer correctly is we have to figure out these origins. So that's the very first thing we want to deal with. So we're going to do just like the instruction said. We're going to open each one of these parts, and SolidWorks is going to try to do the feature recognition. We're going to tell it no. And then I'm going to open the next part, which is the long pin. It doesn't matter what order you open them up in this part of what you're doing when you're putting the assembly together, because we're just trying to open up all the parts into SolidWorks. It's like preloading them in. And then we're going to go to File, and we're going to make a new assembly, because we're making an assembly where we're not loading in any parts right away. And then I'm going to do my little pin like I showed you guys in the beginning of this video, and I'm going to start by loading in this long pin, and I know I need 2 of those, so I put 1, 2, and I'm just going to put one of these chains and one of these short pins because I know I can use Control on my keyboard to make several of them. I think I need 3 of those, and I need 4 of these. You have to unselect it every time. That's kind of annoying, but still easier to do it that way. So now I got everything together, and the first thing I'm going to look at is this origin, and there's the origin of the assembly. You can see it as this little blue dot kind of in the middle of my screen. So the origin of the assembly and the origin of the long pin we want to be together, because this is where we actually want to measure the center of mass from, is from the origin of one of these long pins, because it's at the top of it there. But SolidWorks will calculate the center of mass from the origin of the assembly. So I want these two to be the same spot, is really what I'm trying to say, in the same direction as well, because an origin has 3 vector directions to it. And this pin is currently fixed, so I'm going to right click on it and turn it to float. And the very first mate I want to make is between the origin of the assembly and the origin of that pin. So when I click on those two, it puts them together, and it knows it's going to align the axis right here, which is very important. And that's the very first mate I make. And now you guys can just put this together really fast, because as you guys get good at doing these mates, you're going to go a lot faster at it. I kind of showed you in the last video how quick this can be put together. I think Justin does it even faster than me, to be honest. So I'm kind of quick. He's good at clicking these little check marks over here. I'm used to going all the way over to the left. You build habits in SolidWorks. It's kind of funny. Oh gosh, no, that's not what I wanted. Escape. Escape is my friend as well. Like whenever I misclick something, I hit escape fast. Oh, I escaped all the way out of the mating tool. Escape is still my friend. I love escape. It gets me out of trouble in SolidWorks. But I'm just doing all of the concentric and coincident mates that I had showed you guys in the beginning of this video. This is exactly what you want to kind of do when you're working on one of these assembly assignments. Oh, I have way too many of these links in here. I feel like I somehow replicated way too many. Maybe it was working when I didn't realize it was. I'll just delete them because I need 4, right? 1, 2, 3, so one more. And this guy. Check mark. Concentric, and then coincident. Lining up everything there. And then this green pin goes through there. And I think it goes the same way, so we're going to go that way. Yep. So then anything else I have in here was too much, so oopsies. So I'm done using the mating tool, I get out of it, and I'm going to right click on these and I can delete them. And it's like, are you sure? And I'm like, yes, I'm sure. Delete. And delete. See, you guys still get to see me make mistakes. Isn't this exciting? You see how to fix things on the fly. Wow, I made so many of them. That is kind of remarkable. Yeah, every time I was clicking on it, it must have been making one, but they were just right on top of each other. So you could still kind of move this thing around if you grab it piece by piece. So I would kind of move it in the way that you're supposed to be looking at it. Remind yourself where the origin is. There it is right there. So then go back to the picture, and we're trying to do A, B, and C. So the first mate, I kind of put it in the direction that I want it because it's a little easier to click on when I'm doing that because A is going that way. So when I hit mate, I'm making a angled relation for this mate, and it's going to be between this surface and that surface. And it already went the wrong way, so I hit flip direction. And now that's the way I want it. And this tells me to make a 25 degrees. So I have to make it 25 degrees to start with because the global variables are stupid in assemblies. The next one goes this way. It's already kind of tilted that way, so I'm already in the mating tool. So I want to make an angular relation between that surface and this surface, and it flipped it again. I don't know why it does that. And this one needs to be 125. And that's not right. That's not right either. Just click all the combinations till you find it. There it is. That's the one we want. Check mark. And then the last one was 130 going that way. So another mate. It's going to be an angle. And it's going to go from here to here. And I want it to be 130. And it went all crazy. So I just start clicking buttons over here until it goes the right way, which there it is. So that's all 3 of those. So then if I want to, I'm done with the mating tool, so I can get out of that. But I can click on my mates to look at the mates I made. And when I click on angle 1, I can see the 25 degrees there. And if I come double click on the 25 degrees, I could turn it into a global variable like I showed you guys in the other videos, where it asks me if I want to make a global variable, and I tell it yes. And I could do the same thing to all 3 of these. I just go in there and I update it from its finite value to a global variable value, which is already going to be assigned for the exact same value as the finite value. So it's just updating these to where when I do want to go to change them, it'll be easier. So there we go. I got them all updated. And when I go to evaluate, this should already all be pointing in the right direction. So rebuild. And let's go look at our answer, because I don't remember. So we think it is answer number 1 at 348.66 and negative 88.48 and negative 91.40. And when we go look at the solutions at the end, there is the correct answer as well. So my advice, as always, is just do it right the first time, right? Like, if you just do it in a systematic way that you know it's going to work, then you're going to succeed more. And what I did differently than what I did in the other, or the beginning of this video, is I started with paying super attention to where that origin was and trying to make sure things were oriented correctly right off the bat, which I confirmed by making sure this was actually going to be the center of mass is calculated from the origin of the assembly. So I made sure that the origin of that assembly was right on the top of the origin, or the top of the cylinder, which was conveniently the origin of that cylinder. So everything was able to line up nice and easy for me. Sometimes you have to tell this face to be parallel to the front plane. That way it's pointing in the X direction. like on the what I had did last night, and what I don't want to post a super long video for, was I actually had this pointing the other way, so it was pointing in like the negative x direction, which gave me wrong values for everything. Um, so just pay attention for things like that. So if you have like the right numerical value but it's negative, that just means it's like pointing the wrong way, and understand your coordinate systems. So this should be able to be put together really easy, and then we're going to do the other part of that test. So it wants us to change it to 30, 115, and 135. So if I right-click on equations, manage equations, and change this one to 30, 115, and 135, and then update everything, and recalculate the center of mass. Here's the new values. So the pre-test from my experience has also been this exact same way, to where when they have you update these values, they only change slightly. So if you get a dramatic change, like if one of these values changes horribly, or if the way it changes doesn't make sense, so again, understand what positive versus negatives means in each one of these fields, then that's a red flag that something went wrong. So we got, let's see, we changed it, oops. Let's see if we match the solutions here. And 32767, negative 9. Yep, so those all still match. So the global variables worked, and positioning it worked by aligning those axes off the cylinder and the origin of the assembly. And there's, like I said, there's lots of ways that this can go wrong. So I may crop in some of the other stuff that went wrong at the end of this video just so you guys can see if anybody's curious. But I probably won't put too much because it was super long last night. Thanks, you guys.